Imagine you have sensitive files you want to share with third parties. And you want to do this in line with all the certifications, all the compliance rules that apply to you. You probably use a tool that is available somewhere that you can buy, right? It needs to be secure, it needs to be compliant and everything. That's what many customers did, and they chose Accellion. Now guess what happened next? Welcome to Threat Talks. My name is Lieuwe Jan Koning, and from the Security Operations Center floor here at Onto we bring you Threat Talks. Let's get on to it. Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity. Let me introduce my two guests of today. Timmermans, he is the CISO of Onto and his job is to keep everything secure. And on the other side, it's Luca Cipriano, he's a threat intel specialist and he knows all about threats, and in particular the one that we're going to discuss today. Luca, could you explain a little bit what is this Accellion thing and what happened?
So Accellion is a secure file transfer, as you mentioned at the beginning. We touched similar software already in one of our previous deep dive. It was the Move It. Probably people are going to remember it. And it is used to transfer file in a secure way between users. This Accellion specifically, they also did email encryption, but also it's used to audit file and check if they meet compliances standard. This attack had a really big impact because 300 customers from Accellion were affected and 100 of those were actually breached. Between the one breach, you had the Reserve Bank of New Zealand or Shell, for example. So big names, as companies. And the problem is that this software, at the moment the attack happened, was a legacy software. So Accellion, they already, as a company, created a new software, and most of the customer already migrated to that one. But this one was still was not yet end of life, but it was legacy.
But the software itself was still considered to be compliant because that was initially the reason why it was chosen as the preferred software by so many, also bigger organizations, because it meets the PCI DSS requirements, the HIPAA for healthcare, the FISMA, and all other types of regulations, regulatory compliance. It was provided to be a secure solution, and that's the reason why it was selected by so many parties. Is
the fact that it's legacy, maybe we should define what legacy is, but is this a common thing that happens in when security frameworks are there to, of course, prevent legacy from happening in a negative sense?
Yeah, so we see that indeed this was a legacy solution. It was to be phased out, but it was still in use a lot. The
security
solution
applies until you shut off everything.
Yeah,
right?
Indeed. Yeah,
I guess it's even if his legacy still ticks all the box to be compliant. So that the fact that his legacy does not mean that it's not compliant anymore. But probably since also the company had a new software already, maybe it gets a bit less attention in terms of patching and security updates. So that maybe what caused also this a bit, and that does not make it non-compliant, of course.
Well, let's see how many vulnerabilities they used. Huh?
Yeah, well, that's the funny part, because actually this one is one of those kind of complex attacks like we've seen already before, that they used actually 4 different 0 days to achieve the goal. And that makes it quite sophisticated. And most of the attacks were carried by Klop ransomware, which is quite famous. They're Russian-based cyber criminal. So they do ransomware extortion and this kind of things.
If there are 0 days, I mean, the fact that there's a new application now that is not legacy, I mean, wouldn't they suffer from the same 0 days then? Because it's a 0-day patch management will not help you.
Well, I assume that and I hope that when they create a new application, they start from scratch. They don't build on what exists anymore, but they create a new...
The underlying technology was so old, it obviously that would be...
Yeah, as I mentioned before, probably it was being legacy, and with the fact that they created a new, more up-to-date software that was more feasible also for cloud computing and this kind of things, they probably maybe were not paying so much attention to the security updates, patch managing, and what it is old. Also because some of the customers already migrated, so they were not using it anymore.
And keep in mind that they are 0 days, so they were not previously known vulnerabilities. So also that is the challenge with a lot of organizations in general, but also in this case. Okay, how do you deal with those 0 days? And that also involves, for example, testing of the application, because well, you have hackers that are testing it, but for wrong purposes.
Yes.
But you can also test it yourself by doing a pen test or having a red team exercise, etc. So find ways to get in and to maybe find these vulnerabilities and exploit them yourself, so you can be ahead of the attacker.
Yeah, recently we talked in a previous thread talk about compliance and actual security. And one of the conclusions was, you gotta always be on the ball and mention the details, take care of those, and don't let that go, even if it's unfortunately if you're not making any new money anymore on that product. Huh?
Yeah.
So what do they do?
Okay, so it is difficult to tell the order where how this 0 days were exploited, but for sure the first thing that they did, they exploited an SQL injection via a crafted host header. So SQL injection, we explained it already in the past. Just quickly, it's a programming language used to deal with database SQL, and malicious code was injected. And the host header is normally what the user visits, like that has the domain and the page that the user wants to visit.
It's what your browser sends to the server to say, hey, I want this.
I want this,
that's
yes,
in the host
exactly.
header.
So what they did, they added an SQL injection. So, for example, a piece of code from SQL in the header that was passed and executed. And this happens, for example, when maybe for some calls or some functions, the header is passed with the code, but is not sanitized. So
for the nerds amongst us, you can in the GET request put the SQL injection in the URL. That's probably easier to detect. So they put it in the host header.
Yes,
which also plays a role in the backend.
Because probably the host header was passed in the backend for running some function or getting something from the database. And due to the lack of sanitation, also the code injection was passed. So that's how they initially managed to retrieve a security key, which then that key it is used, for example, for administrative tasks, but it has a higher admin level. So they were able to use that to perform
initial access.
Extra stuff.
And typically from a security perspective, what you want to do is to prevent the possibility for SQL injection in the first place. So if you are knowing what would be the input, you can sanitize the input, or you can block certain characters or certain commands that can be executed. So if you would have that implemented, then you would only allow certain type of inputs to be accepted, and the rest would not work in that way.
This is in software development lifecycle.
Yeah, so it's.
we have the same, and there's one thing that you always escape everything. If it has to do with SQL or user framework, escaping is the answer, right? Apparently, they didn't do that.
Yeah, and this is typically something also because it's an application. Well, it was already quite some years old, so it was. Probably built initially also years before that.
When hackers didn't exist.
Well, maybe there was less awareness of this specific vulnerability.
Hacker existed already when there were no computers with phones and this kind of things. Yes.
Like the 2600.
2600, yeah. So
we'll put a link in the show notes, what that means.
But anyway, so we were at the point when they retrieved this key, and of course now they need to use this key because they just have like the key of the kingdom. And how did they use this key? Well, this where the second 0 day comes into play. It's operating system common execution via local web service call. It's a bit complex to say, but what happened is that this key allowed them to communicate with an endpoint not as a computer but as a part of the software that is there, and this
API endpoint,
yes,
the URL,
exactly.
Okay.
And with this key they could use it to access a legitimate utility from Accellion, which is called admin.pl, which is probably a Perl script or something. And that allow them to write a web shell, an evil web shell. So evil functions are used to pass strings and be executed as into code. So this way, the attacker could send a post request with the command to be executed in the evil web shell and executed on the host. Unfortunately, the software was also vulnerable from server-side request forgery. So that means that through this evil function executing commands, they were also able to communicate with parts of the software that normally are not exposed to internet, so that they are used to access internal resources or internal parts of the network that normally a user is not able to access. But in this way, they tricked the system thinking that was the server sending those requests. That's why it's called server-side request forgery.
Server-side request forgery, isn't that in the OWASP top 10?
Yeah, well, it's, and SQL injection is also so there are not new types of
Tim is always
vulnerabilities.
asking us all questions in the development department everywhere about this stuff. So
he knows, indeed. Yeah, you're almost getting tired of it.
I think they don't like security guys.
We're like, did we have an oversight? And
So, but in this case, also, restricting the traffic, of course, having also for the interaction itself with the end user web application firewall that is able to detect certain types of behavior or deviations. Those are also measures to be considered. But you see that for this type of attack, that a lot takes place during the development phase. And so this development life cycle, where if by design these weaknesses could have been considered and are implemented, and you have the right checks and validations in the code, then that could have been preventing these exploits from happening. And as Luca said, it's kind of consisting of multiple stages. So if you have this chain and you can at some point break this chain because the attacker cannot proceed, then there will not be in the end a successful attack.
The earlier you fix the bug, the cheaper it is. So when you're coding, Okay, so we are now at 2.
Three basically, kind of. So then we have the fourth one, 3 if we count the server-side request forgery. That was also a 0 day. The fourth one is OS command injection via a crafted post request, which helped the attacker to gain even more elevated privileges in the software itself, because with post requests sent from outside, they were able to run commands on the OS. So at that point, they could really have access on the lower level of the software of the OS and do additional damage.
Yeah, and in layman's terms, I think what this means is by just sending a packet to an appliance that's installed somewhere, you execute a command on the appliance itself. So you're in the middle, you're completely controlling everything.
You at this point you control the appliance. So then you have the OS. You can access the OS and read, write, delete file, all this kind of things.
The passwords, transfer the files out probably.
Yeah, you can do a lot of things.
Add the user that can 3D download everything. Yeah.
So how did they achieve this? The exfiltration. They most likely used the evil function to create a web shell that is called due mode that was used for this specific case, and it is a web shell that, in practical terms, it provides the attacker with kind of a GUI version, so the attacker can see a web page, a new web page from where the attacker can enumerate all the files that are stored in the software, but they can also download them, delete them, change it. And
they made their own God mode admin.
They made their own God mode admin console. And what is also quite I would say good about this web shell, but bad, depends on the point of view, is that they had function also to clean their traces. So they were able also to delete all the temporary files that were created, the scripts that they use, and all this kind of thing. So that makes detection and forensic investigation more complex on a later stage. What they did, of course, being like a ransomware gang, they, of course, downloaded the data and then they sent ransom notes saying, hey, if you don't pay us, we're going to publish all this data. And as you can imagine, given the fact that this software is used mostly by healthcare, governments, finance institution, there was a lot of data, valuable data.
Their most valuable data, probably. Yeah.
Yes, indeed.
Yeah. And
Any advice, Tim?
No, well,
if you suppose you have something like this in your own organization.
Yeah. So it's quite difficult, of course, to because you are looking for a solution that enables you to transfer the securely transfer sensitive files. So yeah, that is something that not a lot of organizations will build themselves. So looking for something existing. Well, that presents a challenge because then you are often looking at a third-party solution and you don't know exactly how they secured it. Well, in this case, they did check all of the compliance boxes. They were certified. They and for
probably legally fine. But that doesn't mean your data doesn't get stolen.
No. And this is always, of course, there are always residual risk, and also as you know, especially also during development, there can be bugs or there can be 0 days, and also unintentional, of course. So that's also something to keep in mind. Also with frequently testing your software and the quality of your code as well for these types of cases. But as an organization looking for a solution like this, the certification is often where it stops. Like, it's PCI compliant. We need to be PCI compliant. We need to have that type of solution. Fine, we buy that one.
Yeah, that's the case when compliance induces kind of a fake sense of security, because I mean, you think that compliance is everything. You're compliant, then you are secure, but that is not the case.
No, it's no guarantee, but it certainly helps.
Yeah, it helps, but it's not 100%. And maybe also compliance should add also, I don't know, kind of a check on legacy systems, or have like.
Don't stick around with a previous version for too long.
Yeah.
Previous product.
And that also depends on the type of framework or requirements that you implement. So to what detail is that? To what is that detailed, or is it more generic? And regularly patch or regularly update. Yeah, what does that mean?
Yeah, if your application did not receive an update for let's say a month or so, something is wrong.
Yeah,
that's fair to say. But how do you know in a SaaS solution?
Yeah, in the SaaS solution, the dependency is even larger, of course, because you have no visibility.
You don't know what they're updating. So it's almost impossible to figure it out. And you hope that the auditors do a good job, but we have already established that there's a limitation. So
there's a limitation, and that's also something to accept, maybe as a residual risk in the end.
There's no other way.
Yeah. There's no other way. In some,
and the remediation plan should be ready.
And maybe also checking, for example, with these files, if they're transferred, they probably are transferred for a very short period of time. You know, someone sends
policies, configuration management of the tool.
So also within the existing tools, what are you able to do as the user, as the organization itself?
All right, gentlemen, thank you very much for those insights. Hopefully, in the next thread, there's more we can do as customers. There's some infographics in the show notes, dear viewers, where we lay out exactly how this attack happened. You can use it for your own presentations, or to use it as an example case in your own organization to practice what you would do if something like this happens. Tim, Luca, thank you very much for being here. And if you liked this video and like this podcast, please like it and subscribe to it. If you like it, it allows us to spread the word further, helps us a lot. We would thank you very much for that. And if you subscribe to it, you'll be sure that next Tuesday you will have the next episode ready in your inbox. We'd love to hear from you. Email us at team@threat-talks.com or leave something in the comments. And from the SOC floor here at Ontoit, thank you very much and hope to see you next time. Thank you for listening to Threat Talks, a podcast by Ontoit Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.